Welcome to the second session of the fourth module, where we will be discussing about the availability of the wind in India. No, it is only because the wind is been very uncertain. It just keeps varying from place to the place, and even it keeps changing from day to date and time to time. Now, the wind generation may not be quite enough in all the places where it can generate the same amount of power or enough good enough to convert that power into electrical energy. So it just keeps varying. And one more interesting thing is this wind generation, wind does also makes the clouds movement. Is it clear? So that is the reason why this wind is become a very important factor for analyzing to place or to plant the windmills or the wind turbines. Now, basically, this data is been collected, wind behavior, depending upon the use of intended to be put into the hourly mean wind velocity as collected. It depends upon the latitude, altitude, and topography and scale of hours. These factors are greatly influenced by the wind availability. So this wind availability is a different for different uh, zones or areas of on the earth. And few occasions, even in a few of the countries, the windmills they have placed it in the ocean itself. So that means wherever it is available, they want to extract or harness this wind energy into electrical energy. Now, when it comes to this, in India, the wind power in India, preliminarily assessment along the coastal line have indicated prospects of development of offshore wind power with nearly 24 gigawatts of wind power capacity. India ranks fifth in the world. The harnessing 24 gigawatts of wind power capacity has been harnessed in India. When it comes to the world list, India stands fifth in the list when achieving or harnessing this wind power. India also has an ambitious plan of increasing wind energy share in the 12th 5-year plan. The 1600 megawatts or 1.6 gigawatts of Jaisalmer wind park is India's biggest wind farm. Jaisalmer actually, if I'm not wrong, it comes in the zones of Rajasthan. It can generate 1.6 gigawatts of power. That is the one of the that is the biggest wind farm in India, which has been developed by Suzlon Energy. Suzlon Energy, even we can see this many. If you have seen a windmills, there itself they are the pioneers for this energy harnessing. The project features a group of wind farms located in the Jaisalmer district of Rajasthan in India. So Suzlon Energy Systems are the one people who have planted this and extracting electricity from this wind energy. Wind energy has spread across the south, west, and north region of India. The potential of wind energy is concentrated in the states of Andhra Pradesh, Gujarat, much in Karnataka, Madhya Pradesh, Maharashtra, Rajasthan, Tamil Nadu, and Telangana are the few other states who are majorly concentrating on this wind energy harnessing, and they are also extracting the power. They have got a higher potential. It is not because the other states why they are not trying. It is only because, my dear friends, the first and major reason is the wind energy should be available. It is not the same for place to place, or it may not be same for the hour to hour. It keeps changing with respect to the time and with respect to the day and with respect to the place also. So based on the availability, they will go further. India's wind energy sector is led by indigenous wind power industry and has shown consistent progress. So that is what I was just telling. Even we can make it out. If you see, earlier there used to be only in Chitradurga belt. Now they have started in Hospete and even in Koppal, and even few belts between Haveri and Hubli. In between the place of Haveri and Hubli, there also we can see few of the windmills which have been planted. It is only, my dear friends, the initial investment may be more. While yesterday we were discussing about the advantages, for the unit cost of the energy output that we are receiving it from the windmills, it is much lower than the solar energy. So that is the reason why people are going more for the windmills or the wind turbines or wind energy harnessing. The expansion of the wind energy has resulted in a strong ecosystem project operation capabilities and manufacturing base of about 10,000 megawatts or 10 gigawatts per annum. That means per annum, per yearly, we are harnessing around 10 gigawatts of energy by this. The country currently has the fourth highest wind installed capacity in the world with a total installed capacity of 35.6 gigawatts. It is not a small number. It's a huge amount of power that is being achieved, and it has been constantly increasing. The wind power harnessing by India, it is constantly increasing year by year, and one of the biggest installed highest capacity, the fourth highest wind installed capacity in the world is with the total installed capacity of 35.6 gigawatts as on 31st March 2019, and has generated around 52.66 billion units during 2017 and 18. Now, you believe it or not, one of the windmill which has been placed in Germany, if I'm not wrong, it is in Germany. It is so big. That means if you have seen this blades and there behind that there will be a turbine. Okay. Now about this turbine there is a been helipad. An helipad is been made on the back part of the windmills. That means you can imagine how big it must be. Is it clear? The government is promoting wind power projects in entire country to the private sector investments by providing various fiscal and financial incentives such as accelerated depreciation benefits. Now, in the government of India is encouraging more on this non-conventional energy sources by entertaining the private sector and encouraging them to invest in by providing various financial incentives and fiscal support. No, this is only reason because the dependency of industries, the dependency of the companies on the electricity will be reduced as much as it has been reduced. Now, you might have seen, say for example, we depend more on the Raichul thermal power plants. If any one reactor is being shut down, there will be a cut down of electricity will be there. That means we are dependent so much of on electricity, the conventional one. So instead of burning that, instead of depending on that, as much as possible, the government of India wants the industries, companies, and all of us to depend less on the conventional power plants. That is the reason why they have been making more encouragement for this. And even when it comes to the solar energy, not only this wind energy, even when it comes to the solar energy also, they have given more support for that non-conventional energy sources, and they are also giving some benefits also, subsidies also they are giving it. It is only to encourage the use of non-conventional energy sources. The concessional custom duty, the concessional custom duty exemption on certain components of wind electric generators, besides generation based incentives. This is called as a GBI, generation based incentives scheme, was available for the wind project commissioned before 31st March of 2017. This is, it's only to encourage these people who are using or generating the wind power, harnessing it. Exactly. So the basically this wind generation capacity, in particularly in India, has a significantly increased in recent years. As of 28th February, if I am not wrong, 28th February of 2021, the total installed wind power has been raised to 38 or 39 gigawatts nearly. It was it was a fifth, and now it is getting to be fourth highest wind power harnessing capacity in the world. This makes the dependency on the conventional electricity less. Nowadays, even the Tamil Nadu is competing with the other states in installing the largest number of wind power generations capacity in India. Basically, this wind power generation means getting some electrical energy by converting wind energy in rotating energy, and by the blades and converting the rotating energy or mechanical energy into electrical energy. Now, how much ever the wind speed is there, so much of electricity will be generated. Now, when I come to the principle of working of a windmills, I just shall explain you. It may not rotate very fast, but it should be constantly rotating. How much ever it keeps rotating, so much of energy will be generated. No, because it is huge. Even if it makes one complete revolutions, because of the gear system arrangement, we have it sophisticated and advanced gear system arrangement from mechanical engineers makes it to multiple the rotations. How much ever it multiples, so much of mechanical energy will be generated. Thus, generated mechanical energy will be utilized for converting it into electrical energy. Okay. Now, I have given a list of the wind potentials in megawatts. There are 16 states which are competing actually. If you take a Gujarat, so it is 84,000, I mean to say 84 gigawatts of potential it has. And Rajasthan, if you take it, 18.77 gigawatts it is available. And then the top one is the Gujarat, and now the Maharashtra is also having a 45,394 megawatts of energy windmill potential. And now Tamil Nadu, now actually Tamil Nadu it is now increasing. They have rapidly increasing and encouraging more for this uh, capacity to increase the capacity. And Madhya Pradesh has got 10.483 megawatts. Now, if you see this Karnataka, especially this is the Karnataka has got around 55,000. This is the second in the list. This is the second in the list. Now, India is in the fourth, competing for the fourth position in the world, and Karnataka, in which it has got a second spot. Now, if we look at into the Andhra Pradesh, this is a old statistic, so it is only the Andhra Pradesh. If you see this, 44,000 it has got, whereas the small states like Telangana also has got 4.2 gigawatts of energy wind potentials, and Kerala has got 1699 megawatts. Odisha has got 3093, that is 3093.47 it has. And these are all the small actually West Bengal is not a small state to be frank. Chhattisgarh, Puducherry, Lakshadweep, Goa, Andaman and Nicobar, they are all very small states, but still they have got a good potential. If you see this, Chhattisgarh has got 76 when compared to the area available for the West Bengal, it is much smaller, but still they have got around 76.59. It is almost 20 or 40 times more than the West Bengal's capacity. So it is only because I'm not blaming or I'm not commenting on anything why they have not gone for the higher wind potentials. It is only because, as I have already told you, it should be always dependent on the availability of the wind force. Say, for example, if I want to have a windmill in Haveri, it may not be possible. The wind potential should be there. Then only we can go for that harnessing of this wind energy. So it depends on the altitudes, it depends on the latitudes, and it also depends upon various factors which influence these wind potentials. Okay, so the total in megawatts it is around 30, that is 30.2, 302.251 gigawatts, whereas total in gigawatt it is 302 gigawatts of energy which is being available. Wind potential. I'm not talking about the generation. It is only the availability of the wind potential. How this wind is being generated? This is a very interesting one. Very interesting one actually. How this wind is being generated? Wind results from the movement of air due to atmospheric pressure gradients. Pressure depression. What we mean to take. Sometimes there will be a cyclone. Cyclones are always caused because of the depression in air. Is it clear? Depression in air always causes because of the atmospheric pressure gradients. Whenever there is an atmospheric pressure gradients, there exist a depressions in the air which causes a wind currents to flow. This is a very predominant one. Even this wind may also leads to the variations in the wave and tides also. And this also influences the movement of the clouds also. So this wind is predominant in all deciding factors. So the wind flows from regions of higher pressure to regions of lower pressures. Okay, so from higher pressure to the lower pressure, obviously the by the common sense or by the law of physics, what happens? It just comes from higher pressure region to the lower pressure region. That is what we call it as a depression. Wherever there is a depression, it flows like this. Is it clear? The larger the atmospheric pressure gradient, the higher the wind speed, and thus the greater the wind power that can be captured from the wind by means of wind energy converting machineries. Wind energy converting machineries are nothing but wind turbines or windmills. And even in this windmills and wind turbines, we once again classify into horizontal axis and vertical axis. And when we use a horizontal axis and when we use these vertical axis, that I just shall come to that in the later part of the lecture. The generation and movement of wind are complicated due to a number of factors. Among them, the most important factor are uneven solar heating, the Coriolis effect due to the Earth's self-rotation and local geographical conditions. So these three things, the Coriolis effect is the one thing I just shall explain next in the next slide, and then the uneven solar heatings, and then the local geographical conditions. Now what happens? This first and foremost thing is uneven solar heating. As I tell you, the solar radiations which are coming will not do any differentiation. It is with the same intensity it will be coming in extraterrestrial. Once it enters into the terrestrial region means when it enters into the surface of the earth, it differs. That is what we call it as a local geographical conditions. How this local geographical conditions depends? It is only because the earth is not a flat surface, it is a spherical one. So what happens, say for example the mountains and hill stations are more, and the normal ground level area is also been there. So the air which is on the ground level and the air which is on the hill stations will be heated indifferently. It may be because the greeneries, it may be because of the altitudes, it may be because of the air circulations. So what happens? Because of that uneven heating, the air will also be heated unevenly. So that makes the air to go to the lower regions, whereas the hot air will tries to move upwards, whereas the cold air will tries to move towards the downwards. It is something like, my dear friends, in AC, in air conditioner. Have you seen every time basically exhaust fans? When you go for a theaters or a malls or wherever you go, exhaust fans are always placed at the top. Why? The exhaust fans are not at the bottom. Why? The reason is Any hot air, any hot fluid will loses its weight and becomes lower dense. The density reduces and its weight also becomes less, so that it will move upwards. The lower density or a hot fluid will move upwards, so that what happens, the cold air or a cold fluid will comes and settles down bottom. Is that clear? So that once the hot air moves upwards, it has to be expelled out. That is the reason why we always will have a higher elevator, that is at the top or the at the height, we will have an exhaust fan. So similarly, what happens when the air on an uneven surface of the earth is being heated unevenly, so the hot air will tries to move upwards and the cold air will comes at the bottom. So what happens, due to this there will be a circulation, or there will be a formation of currents of movement of this air. So the temperature difference or the density difference makes the buoyancy forces to move. The severity of these buoyancy forces makes the wind velocity more strong. Is it clear? So that is nothing but uneven solar heating. So similar occasions, this also happens when the air above the water level or the water, it may be a river or it may be a sea or it may be a ocean. So what happens, the air above the water and the air above the land will also be unevenly heated, makes it to move once again the currents. That is the reason most of the cases this depression will be severe in the coastal sites compared to the innermost region of the land. In the coastal side, what happens, there will be more air will be on the water than on the land side region. So that depression makes it to be more severe. This is the depression causes the air to blow with a very high velocity. And next, when it comes to the local geographical conditions, I just meant to say the local geographical conditions. Say, for example, if you go to Hospete or it may be Chitradurga, where you will see a series of mountains. When it comes to the Haveri or any other places which are very normal, you don't find any peaks or mountains or hill stations. So that is what it means to be a local geographical conditions. When it comes to the Coriolis effect, this is because of the rotation. This is because of the rotation. If you take a ball, if you take a ball, if you take a ball and if you rotate it continuously, if you rotate a ball continuously, the air which is being above this will always varies, will always moves with higher wind velocity. Is it clear? You take a air when the ball is like this, and if you rotate it, what happens? Will it be same? No. This is what a simple Coriolis effect explains due to the Earth's self-rotation. I just shall come to that later on with the next slide. So this is what I just have told you. Now this is uneven solar heating. I have already explained once again. Among all factors affecting the wind generation, this is the major factor which causes the wind generation. Is that clear? The uneven solar radiation on the Earth's surface is the most important and critical one. The unevenness of the solar radiation can be attributed to four reasons. There are maybe four reasons due to which it may cause the uneven surface of heating. First, the Earth is sphere. No, one more thing. This is the reason why cyclones are more effective on the coastal sites. Whenever we hear, now even today also there is a cyclone, it is only because the depression in the air that makes the cyclone more stronger. Is it clear? So the unevenness, the first thing is the earth is a sphere revolving around the sun in the same plane as its equator. Because the surface of the earth is perpendicular to the path of the sunrise at the equator but parallel to the sunrise at the poles, The equator receives the greatest amount of energy per unit area, with energy dropping off towards the poles. If you consider this is an earth, if you call this is an earth, now this is called as a north pole and this is called as a south pole. This is the north pole and this is the south pole, and this will be rotating along the equators. So equator is something like this, which will be here. Okay. Now most of the occasions, now in all the occasions, what happens? The maximum solar radiations which will be falling will be on the equator, and even the earth will be rotating along the axis of this equator. So what happens? Maximum solar radiations will be falling onto this equator perpendicular in direction, whereas this north pole and south pole will not be exposed to much of the uh, solar radiations. So that is the reason why what happens, these solar radiations which are falling onto this uh, equator will be exposed more, and these surfaces will be heated more, with energy dropping off towards the poles. Due to the spatial uneven heating on the earth, it forms a temperature gradient from the equator to the poles and a pressure gradient from the poles to the equator. This is the reason why the from the equator, from the poles to the equator and from equator to the poles, whatever the difference is there, that makes this air to circulate, that makes the wind to blow with certain velocity. Thus, hot air with lower air density at the equator rises up to the high atmosphere. So this is what the hot air over here will rises to the top. Okay, whereas the cold air will comes moves towards the poles, and the cold air with higher density flows from the poles towards the equator along the earth's surface. Is it clear? Now this is a hot because it has been exposed to 90 degrees perpendicular solar radiations, so that air over here will be hotter and it will move towards the poles, and whereas the cold air which moves bottom or moves towards the not bottom, it is moves towards the equator. This is how it just happens. This is the first way that uneven solar heating might occur. Without considering the Earth's self-rotation and rotation induced the Coriolis force, the air circulation at each hemisphere forms a single cell defined as the meridional circulation. This is what we call it as a meridional circulations. If you consider the second one, the Earth's self-rotation axis has a tilt of about 23.5 degrees with respect to its ecliptic plane. That means it is not exactly like this. It is not exactly 90 degrees it is rotating. It is tilted like this. It is being tilted like this with 23.5 degrees with respect to the elliptical plane. Now I always tell you, sun is not revolving across the earth is not revolving across the sun with respect to a circular one. It is an elliptical orbit. Now in particularly this earth is not perpendicular like this and it is rotating like this. It is been tilted like this with 23.5 degrees with respect to its elliptical plane. It is the tilt of earth's axis during the revolution around the sun that results in cyclic uneven heating, causing yearly cycle of seasonal weather changes. This is the second one. Okay, because of this tilt, what happens? Revolution around the sun that results in cyclic uneven heating. Cyclic uneven heating is nothing but summer, winter, and then rainy seasons, which are making this. Is it clear? So that makes the weather to change. This is the second reason. And the third reason is that the Earth's surface is covered with different types of materials, such as vegetations, rock, sand, water, ice, snow, etc. That is what I was talking. It may be a greenery or it may be a water which has been covered. Each of these materials has a different reflecting and absorbing rates. to solar radiations, leading to higher temperature on some areas like deserts and low temperatures on other, that is iced lakes or water, even at the same latitude. Exactly. Though the deserts and the ice lakes are on the same latitudes, because of the material properties of reflection and absorbing makes the air to heat unevenly. Okay. The fourth reason for uneven heating of the solar radiation is due to the Earth's topographic surfaces. There are a large number of mountains, valleys, hills, etc. on the Earth, resulting in different solar radiations on the sunny and shady days. This is what you can appreciate this. So I have already explained this. So the first one is because of the uneven heating of Earth to the equator to the poles. Second one is because of the tilting of the Earth orientation towards 23.5 degrees with respect to the elliptical plane. And the third one is because of the material properties for the greenery or maybe desert or an ice, though they are maintained at the same latitudes. That is what the third reason. And the fourth one is because of the topography of the surface with a lot of mountains, valleys, and hill stations. These are all the reasons, four reasons for the uneven heating of the surface. So if you see this, this is the North Pole and this is the South Pole. I should have given you before this. No, this is the westerlies and this is the trade winds. Now you can see this. This is the poles and this surface. This is an equator at 0 degrees. As I have already told you with some examples here. This is an equator. This is an equator and this is the pole and this is the pole. This is North Pole and this is the South Pole. This is how the air goes around polar cells. This is a polar easterlies. Is it clear? This is how the uneven heating makes the wind energy to generate. Okay, thank you.